Welcome everyone. Sandman, the speaker of the next talk, is the Director of Technology at Inflector Corporation. He is experienced in architecture, agile development, testing, and project management. Adam has been researching testing-related processes for years and is eager to share his knowledge. In the last 4 years, he participated as a speaker in more than a dozen events. Today, he's going to tell us how to balance different testing techniques and how to use a risk-based approach to improve the testing coverage. Welcome, Adam, and enjoy the talk, everyone.
Hello, thank you so much, Roman. It's a pleasure to be here. I'm actually sitting here in Washington, D.C. in the United States, but I was hoping to be there in person, and hopefully next year I will be there in person. I have never been to Lithuania, and I've really wanted to go for a long time, so I'm really hoping to be there in person next year. But it's wonderful to be here virtually, nevertheless. I'm going to be talking today on risk-based testing, and with that, I'm going to share my screen. So 1 second while we switch over. All right, and slideshow. Awesome. So, are you ready to run the risk? Which is my fun title to a very actually serious topic, risk-based testing. It's an approach that has become very popular, but I feel like it's not necessarily well understood, and it relies a lot on the ideas of risk management, but applying it very specifically to testing. So first of all, before we jump into the details, just a little bit about me. Roman gave you my official bio. I've been a programmer actually since the age of 10, so I've always been very interested in technology. When I started out, computers were 8-bit computers back in the 80s. And in fact, if you click on this link in my slides, it will take you to some computer games I wrote when I was 10 that are still available, and you can run them on an emulator today. If you want to get hold of me, if you're interested in any of the slides or any of the other questions, my Twitter link and LinkedIn link are there. These days, I'm doing more on LinkedIn, I must admit. And as I said, I live in the Washington, D.C. area, but we have a great technology practice at the company, and so I do usually normal years travel around the world, and I've been doing a lot of that virtually. So for today, the key takeaways, I think, if you can remember nothing, would be, first of all, a risk-based approach helps you get better outcomes, and I'll explain why that is. I also want to talk the second thing about how you can use metrics that you already have in your project today to create what I would call a risk-adjusted test plan. So when you create test plans, I'm sure there's a variety of techniques you're using. This is one technique you can use either by itself or in conjunction with other techniques you're already using to improve the coverage of your tests and focus where the testing is most needed. And the classic problem of I'm over-testing the wrong areas and not spending enough time testing the right areas. And we'll talk about what's right and what's wrong later. Because nothing is really wrong. Better test something than nothing. And I'm also going to show you some practical tools you can use. I've got a spreadsheet which I'll be sharing with the PDF to anyone who's interested as well on Slack. So first of all, I'm going to go through a little bit of an understanding what risks and risk management is. I'm not going to assume in this talk that you've ever done much work in risk management. If you're familiar with risk management, it's something you've done already, then please, you can check my slides, you can raise comments, but you may want to skip, wait, some of that's going to be familiar to you. I'll then talk about how you can use the techniques of risk management and apply them to your test plan, and specifically how you will use the risks you've identified to prioritize your tests. I'll then go through some examples of how we've done this and how you can do this, and some tools and tips you can use. And at the end of that talk, we will have time for questions. The talk should be about 40-45 minutes. I do have a tendency to speak fast. I'm trying to be slow to make sure that doesn't happen today. Okay, so first of all, what is risk-based testing? Well, to answer the question, risk-based testing is a software testing methodology or method which is based on the probability of risk and applying risk to the basis of testing. And traditionally, if you've worked in software for many years and in project management for many years, risk management is a discipline. It's quite common in the project management methodology. People who manage projects for a living hopefully are well aware of risk and risk management and different techniques. In the testing and quality assurance domain, it's a newer idea. So traditionally, testers and test managers were doing their thing. The project managers were off doing project management stuff and risk management stuff, usually together. It was in isolation. What we're now seeing is this incredible value in taking the ideas of risks and risk management and applying it to the lens of software QA. So the first thing is, of course, I've been talking already about risk a lot, and it's not the board game, although that is a fun board game. Risk is basically a future event that might happen at some point in the future. And it's really important. People often get confused about this. Many people have bug tracking tools, and they'll create a type called risk, and they'll have bugs, issues, risks, change requests, all this stuff. And then they get them all mixed up. Now, a risk is very specific, though. It's quite different to many of the others. A risk is something that could happen in the future versus an issue, which is happening usually right now. And a risk, if it happens, will then become an issue. But the really important thing is, risks don't have to be necessarily be things that are bad. They can be good too. They're just outcomes that are possible, good and bad. And then you have to try and weigh how likely is that thing. And we'll talk more about that in a second. But generally, risks can be both positive, like winning the lottery. And if you have a lucky day, you'll always say, oh, my luck is really great today. Let me go get a lottery ticket. Same idea. And then the other type of risk is negative, something that's detrimental to the success of the project. For example, there's a risk that the browser that we're developing this for will not be the browser being used anymore. There's a risk that our technology stack is old, all these kind of things. It's something that's possible, but negative. And so you have positive risks and negative risks. Now, the reality is, in project management, for the most part, and in test QA, I will say the same, we're generally going to be focusing on negative risks. There's nothing wrong with obviously considering positive risks. Certainly in project management, you might do that. When it comes to QA and testing, generally speaking, we're not so worried about things that are going to do better than expected. If there's a risk, the load may be too great for the system, but guess what? The system is faster than we expected. Usually, we don't worry about that. And as QA professionals, we're usually too busy worrying about other things to find if something is good and better than we expected. So generally, I would focus on the negative risks. There are different types of risk, first of all. So first thing is there are types of risk. And this is not the only 3 types. These are just some of the types. The 3 main types I have seen on software projects are what we call conceptual risks, technical risks, and schedule/business risks. And under these there may be subtypes. And I remember talking to a person who was the head of R&D for the US Navy, in fact, the United States Navy, and they were building all these crazy new systems, new UAVs, underwater UAVs, various other communications technologies. And they're building really complicated systems that are doing things that no one's ever done before. And she was saying that the 3 things that she worries about are these types of risk, these 3 categories of risk. First of all, conceptual risk. Are we building the right thing? And this is actually often the most difficult to get right, because you can spend all this time getting user stories, getting requirements, developing, testing. You've got this wonderful system that works perfectly. There's no errors. And then you release it into the wild, and it doesn't solve the business problem that you expected, or the business problem is changed. So, it's really important to understand how you're building the right thing. And that's why we do things now like spike solutions, minimum viable product in Agile hubs. There's lots of techniques in Agile to help that. Technical. Well, it might be a great idea, but will it technically work? There are technical risks on any project that you have to try and mitigate. And you can do that with experiments, proof of concept, spike solutions, those kinds of things. And then schedule. And this is the one that we always think about, and it's unfortunately the most common, but sometimes it's the most obvious, but it's often the one that we spend too much time on and forget about the conceptual and technical risk. Schedule risk is, will it be on time? Will the client be ready? Will the infrastructure be ready? Are we really developing the user stories fast enough? Is there enough time for testing? All of the usual schedule. And I would say even business risks could be in here. There are plenty of business risks, financial risks, which will impact the schedule as well. So these are the 3 main, I would say, software project kind of risks. There are plenty of other kinds of risks which might be unique to your industry. For example, if you're building a software system and you're going to be testing it for the medical device community, there are safety risks you have to consider. There are clinical risks. If you're going to be building software for use in aerospace, there's regulatory risks that the regulator won't accept the system, audit risks. So every industry and every kind of project is going to have a unique set of risks. These are 3 good generic categories, or 3 generic types. But I would definitely say if you're going to go down the process of risk management and using a risk-based approach, first of all, with your stakeholders, define the types of risks you're going to be coming across. Now, as I mentioned, there are ways to reduce some risks. And Agile is really great about this. So the first thing is conceptual risk. We all know the problem is that I don't know what the requirements are until I see it. Once I see it, I'm like, oh, well, that's really great. Wouldn't it be good if it did this and this and this? So Agile helps to mitigate conceptual risk by not waiting 6 months to give you a system, but giving you in 1 month a tiny MVP or a small prototype, something that you can see and touch, and then you can look at it, get the feedback, understand the concept, and then adjust course right there and then. Technical risk, spike solutions, proof of concepts, also doing the most technically challenging user stories first to reduce the technical risk. And then the last one, schedule risk. Lots of things you can do here. Scope management is a key one, having good communication plans with the clients or with the end users or whoever's going to be signing off on the system. And again, scope management is often the best one. Don't have fixed scope, fixed time, and a fixed team. That doesn't ever work. Make sure that you can adjust the scope to fit the dates that you have. Now, one thing you can do is when you start to look at the different kinds of risks, one of the challenges will be, am I going to miss risks? So one technique you can do, one of the tools I'll recommend right now, is a risk breakdown structure. So take, for example, all the categories of risk that you can think of. That's like that top level in dark blue, time, people, technology, architecture, infrastructure, financials, marketing, anything. All the categories of things you have to deal with, and then break it down, 1 or 2 more levels. And that will help you find out all the lowest level types of risk. And then from there, you'll actually be able to identify all the risks. So for example, if we look at technology, that's a category of risk. If you go down that category of risk, one sub kind of type of risk would be, we're building on a platform that works today, but the platform's not going to be supported by Java or Microsoft in 2 years. So the platform is good today, but it's going to be obsolete. How do we mitigate? How do we deal with that? Another possibility would be, works for 1,000 users. It's really efficient. It's great. It's easy to build the system. It's going to be very fast to release. But once we get to 100,000 users, it's not going to scale. Maybe we should be using something that's slightly more sophisticated, even if it's not as useful, not as appropriate right now, for example. So these are the kinds of risks you will drill down. And there's no fixed number of levels. Just really, you want to flush out all the categories of risk and all the types of risk that you can think of. And then you should obviously revisit this. Risk management needs to be agile. So using an agile approach, you might spend some upfront time to identify as much as you can, but don't try and do it all at once. You'll need to come back. Okay, so we're going to do that, and then we're going to have a whole bunch of risks. So the lowest level of these will be risk that the architecture is unscalable, risk that the platform is obsolete. So the next question is, okay, well, I've got all these risks. Maybe you've identified, if you're lucky, 100 risks. That's a lot of risks. But that's a good thing. Unlike bugs, where I feel like you want to minimize bugs and get rid of them, and features, you want to have tight scope. When it comes to risk management, there's nothing wrong with having lots of risks, because the risk is there. Even if you don't write it down, the risk hasn't gone away. The risk could be that lightning is going to hit your data center. Now, it's not very likely it's going to happen, but it says it is a risk. Okay, so having lots of risks just means you've identified things. It doesn't necessarily mean you need to spend time worrying about them. In fact, you could argue that by having all the risks written out, you can make sure you will worry about the right things. So first of all, in risk management, there's 2 main measures. One is probability, how likely. You can use different scales. Here we're going to use a scale of 1 to 5. From certain, it's almost definitely going to happen, and rare, it's very, very unlikely. Notice that certain does not mean it's definitely going to happen. If it's definite, then it's not a risk, it's an issue. Impact. Okay, well, it doesn't matter how likely it is, how bad is it? Negligible, marginal, critical, catastrophic. Here we're going to use a 4 number scale, but again, you can use 5 levels, whatever makes sense. And it goes from basically, if it happens, how bad is it? We could live without it, or it'll destroy the company, for example. So we put them together, and we then get what's called a risk cube, and a risk or risk matrix. And this is really important because this is how you will then quantify which risks you should be focusing on. And by putting these together and multiplying these values, and I should say, in this example, I'm using linear values, score 1, 2, 3, 4, 5, score 1, 2, 3, 4, multiplying them together. So the worst risk will be a 20, and the lowest risk will be a 1. You don't have to make it linear. I've seen some people do, 1, 2, 4, 8, make it geometric. You can use, Fibonacci, any numbering scheme, just to weight it. It's up to you. Anyways, the important thing is this. We put them together on this matrix, and things that are in the bottom left, those are things that if they happen, they're not going to be bad, and it's unlikely they're going to happen. Things in that bottom left quadrant, probably you shouldn't worry about. Things that are in the top right quadrant, which is certain and bad, catastrophic, these things you should definitely worry about. Now, one of the things I'll warn you is people tend to focus a lot on that top right and the ones near there, those top four, likely, certain, and critical. Those are the ones that everyone thinks about because, wow, it's very likely and it's really bad. I would almost say one thing not to forget about is things that are catastrophic, but and maybe even critical, that are possible in this sort of middle column here, where it's possible and catastrophic, possible and critical. This is your danger zone because they're still quite likely, but they're still really bad. These are the things that maybe have a 50% chance of happening, or 30%, or 20%. But if they happen, it's going to be very, very difficult to deal with. So don't forget about those. It's in some ways more important to worry about the impact on the probability. Although if something's really, really unlikely and rare, obviously it's less important. So definitely look at this carefully, see how many risks are in each of these segments, and that will help you figure out which of the risks you're most exposed to. And that's the term we'll use. It's not which are the worst risks, which are the most dangerous risks. It's which are the most exposed risks. Where is your company, project, organization, whatever you're doing this for, where are you most exposed? On the top right and the top section in general is, this top right quadrant is definitely the worst. Okay, so now we've figured out we have 100 risks. Of the 100 risks, maybe there's 20 risks that we actually really care about, that we're really exposed to. What do we do about it? Well, we do what's called mitigation analysis. We take the risk and we figure out what can we do to make the risk worse. Not as less worse, not as bad. And to do that, we can do one of two things. We can reduce the probability, or we can reduce the impact. So one thing might be, if lightning hits the data center, well, we've got a second data center, and everything's backed up in real time. That doesn't make the fact that the lightning is going to strike any less probable, but it does reduce the impact significantly. The second thing we could do, I suppose, would be you could put a giant lightning conductor next to the data center, but not on the data center. And the lightning is going to miss the data center, hit the lightning conductor. That doesn't make it any worse if it did hit the data center, but it means it's less likely. So you can adjust either the probability or the impact. You could do both. And so you'll have mitigations. And a mitigation might be addressing one or the other, and you can have multiple mitigations for the same risk. So, for example, in our fictitious example of a lightning strike, one mitigation is to build a lightning conductor, or one mitigation is to replicate the data center somewhere else. Those are two perfectly valid mitigations. They would both be valid mitigations. You can track them both against the risk. And then together, with both those mitigations in place, if we did both of these things, we're going to reduce, let's say, our exposure from a 12, say, to a 6. And so the idea is these mitigations will reduce the exposure from the before to the after. And so what we're doing is we're moving risks from this top right section, where they're certain and likely and critical and catastrophic. We're moving them towards the left, where they're more likely to be possible or unlikely, or marginal or negligible. Okay, so that's risk. This is basically classic risk management theory. Okay, so now what about testing? That's what we're supposed to be talking about, right? So how do we use this in our test plan? Well, the first thing is, let's go back to basics. Testing is a way of managing technical risk, and I could argue it's a way to manage risk in general. Testing on a software project is to manage and understand and reduce the technical and generally the risks in the project, the technical risk particularly. It's a way to understand things and know what are the risks of going live and what are the risks of not going live. And as you know, as a tester, you never go live with 0 bugs. You never go live with 100% every test, maybe passing 100% in every edge case. Many times you'll go live with some acceptable number of bugs, some acceptable number of edge cases that are acceptable to go live, knowing that you're going to fix them in the next update or something, because there's never enough time. And so it's all about addressing what's the risk. And so testing is a form of mitigating risk. And when you go live with a system, it's the same thing. You may, before testing, have gone into this testing with an exposure of X. Now you're going to go live with an exposure of 10% of X over 10. So you've reduced risk by 90%, and the project manager and the product owner have decided we can go live with this acceptable risk. So testing is all about reducing risk. And then the next problem, as we all know, is there's never enough time for testing. And from this Dilbert cartoon from a while ago, we have time for testing, and whether we're doing agile and it's all being done in the sprints, or it's being done after the sprints in a waterfall, or it's some combination. There's never enough time to do testing. So we do look to automate, and hopefully we are doing test automation. But as you know, test automation is also not going to cover everything. There's never enough time to do manual testing. There's also probably not enough time to do automated testing of everything. And even if there is, it doesn't test everything, as we know. It just checks what we know. So we're going to automate some of our tests. Say 20. Let's say it was 20%. We're going to test some of them manually. Now the question is, we've got these automated checks running, and if you've been in some of the other presentations, you'll talk about DevOps and CI. We've got automated checks running all the time, and whether that's covering 20% or 60% or even 80%, whatever percentage of our requirements and code that we're able to test at different levels, that's checking what we know. The next piece will be, how do we take all these risks that we've identified in our system, things that are going to happen, particularly the technical risks for looking at testing, how do we then focus our test plan to make sure we mitigate those risks? Well, the first thing we would do is to go to our risk matrix. So let's go back to our risk matrix, and you can see it right here. And if we sort by exposure, so we're going to start with the ones that are most exposed at the top, and we're going to drop all the way down to the less exposed. We're going to go to each of these risks, which is these on the left, and we're now going to mitigate those. We're going to write tests to ideally mitigate every one of those risks that we've identified, and we'll do it in order of exposure. So we're not going to start with the client team. We're not ready for AUAT, or the software license will be too expensive. We're going to look for the risks that are, first of all, we can test for. So it's really the technical risks, the business and schedule risks, not so much. And we're going to look at the ones that are most exposed, and we're going to then build out test cases on the right that mitigate those specific tests, those specific risks. So taking our top 10 exposed risks and creating at least one, if not more than one, test case for each of those risks. And that's interesting. We did this exercise relatively recently. We're doing some cyber analysis on one of our products. We put in all the top, I think it was top 20 risks, that are threat risks from a cybersecurity perspective. That one of our colleagues went to TestCon in Las Vegas and got to see all the hackers and all the crazy stuff they're doing. And they had the top 20 threat risk or threat matrix. We put that into a risk management tool like this, and we actually sorted it by exposure. And we built out tests, and I'll talk about requirements next, of actually the ways we can mitigate those. So whatever kinds of testing you're doing, if it's performance testing, security testing, this approach is really relevant. And actually for security testing, it's probably the most relevant. So you get your risks, you map them to test cases, and whether you've got tests already or you've got new tests you're going to create, you're going to then put those next to each other. And then we'll get something like this. And I'm going to share the spreadsheet after this presentation. Basically, on the left-hand side, we've got the risks. And on the right-hand side, we've mapped those to probabilities and impacts to give us our exposure. And we've then mapped those to test cases. And I've used the color coding just to keep it simple for this presentation. Risks that are very high, I put red. Risks that are not so high, I put a yellow color or orange, and risks that are low, I put green. And I map the test cases on the right with these different colors. So basically mapping risk to tests. So tests that mitigate really bad, really exposed risks go red. Tests that mitigate less important risks, less exposed risks will be yellow, and so on down to green. Some tests, many tests here are mitigating multiple risks. That's fine. And also many risks may map to multiple tests. So it's a many-to-many relationship. All right. Okay, so that's the first part. Now, what do we do next? Well, we need to look at other parts of the system. There are some other metrics you should look at. So first of all, we've looked at tests and how they map. Let's look at requirements and user stories. On the left, I've got my user stories. And these are the ones that are the highest business functionality. We can look to each of those, and we can map those to risks as well. So typically, you can map a user story or requirement and map that to a risk. And this is actually what we did from our cybersecurity. We actually took all of the risks from all the threats, and then we went down our information security plan, and we took all the ISP requirements, put them on the left, took all the risks on the right, put them together, and we actually changed the priority value of our requirements based on some of the risks that we identified, but also some of these requirements just had, in general, business functionality importance. They're really important features. They're critical to the business. Let's look at what risks they have. So what we're doing is we're looking at business importance, which is how important is the feature to the company, and then what risks are associated with it. And then from there, what tests are associated. The reason we do this is if we can find a part of the system that generates almost all the revenue, let's say you've got a website, much of it is lovely, but there's a really important part that's the order management system, the e-commerce part. People log in, do an order, log out. That's really important. If that breaks, it's much more important than if the blog breaks. I mean, you don't want anything to break. It creates a bad experience for sure. But there are parts of the system, the requirements in the system that are the most important. And so we want to make sure those are covered because that's obviously going to be more important to the business. Let's identify those risks. So mapping your risks to your requirements is really good. It helps you double second guess to make sure that risks by themselves might be identifying things that whilst they could be dangerous, they don't necessarily map to the most important part of the system. It could be catastrophic to the blog, but not catastrophic to the whole system. So that helps you assess what's the impact. Because usually, but not always, but usually if a requirement has a high priority, it's going to have the biggest impact. So the next thing we'll do is take those requirements and look which test cases in my test plan map to those. If I've got 4, in this case, really critical features, make sure that we've got good test coverage. When I go down to the medium level or the low level features, low level business importance priority, it's okay to have maybe less test coverage, because if those features don't perform as well, there are bugs or there's some edge case tests that weren't run, likelihood the impact is going to be lower, because if that part of the system is not quite as good, there are some lingering issues, it won't impact the business. So back to my risk theory, so I stamped it on the top right with impact. So these tests that map to these highest priority business features will have the most impact. Now, the other thing I would look at is testability. This is going to help you understand what is the probability. So we talk about the probability of something happening. Well, if you've got tests that are passing and failing and passing and failing, maybe they're up and down because maybe there's perhaps a flaky test. Okay, there's a probability there. Doesn't mean there's anything real. So the impact might be low. Back on our risk matrix, the impact might be maybe moderate, but there's something going on there. Now, tests may be unstable because they could be flaky tests. The problems in the tests, but there could be a flaky part of the system. Maybe there's a race condition. We've had this before. We have automated unit tests and run, and occasionally you'll get these ones that will, every 4 builds, they'll fail. And you could easily ignore it and say, oh, it's just a flaky test. It's no problem. Well, we did do a deep dive on those, and we found there was actually a race condition. So it was flaky, but it wasn't the test that was flaky. It was the system that was flaky. In certain conditions, you go into a race condition where 2 events were firing in parallel, and it wasn't deterministic which would finish first. And that meant the data in the system was unreliable to an end user, and that was bad. So it wasn't a flaky test; it was a flaky code. It was flaky code. But we could easily have said it was a flaky test that ignored it. So whenever you get tests that are unstable, it increases the probability of something being bad. Doesn't mean it is bad. Another thing I would look for is requirements defect density, which is a fancy way of saying, where are all the bugs? If you've got lots of requirements and all the bugs are with one requirement, maybe that requirement should be looked at, because there's this temptation. If you look here, we've got a bunch of requirements and they've all got 2 or 3 bugs. So this is probably okay. In this situation, I'd probably look at the top 2 and see, well, there's a few more than the others. But we've had situations where one requirement's going to have 8 to 10 open bugs or total bugs. The rest have 2 or 3. If I saw that, that would imply to me that maybe something's going on here. Maybe the user story wasn't well written, and the testers and the developers don't have good consensus on how it's meant to work. And a lot of these bugs reflect that, because usually you shouldn't be getting so many bugs in one user story. I mean, maybe there is an innocent reason, but it's certainly worth investigation. And just like we said with tests being unstable, this means your requirement is effectively unstable. And so you need to look at that. So look at those requirements, look at the tests with those requirements, and make sure you run them, make sure you write more tests, make sure you really understand what's going on with those requirements and drill down deeper. Because again, it's very easy just to write it off and say, oh, there happens to be a load of bugs with that requirement. There's a whole bunch of tests that have failed in the past. We fixed them all. It's fixed. It's great. If it failed that much in the past, there's a good chance it may have some problem in the future. Certainly, unless there's been a major rewrite because of this, there could be future weaknesses. So it's the probability is bad. Again, doesn't mean necessarily it's an important feature. We're not saying that's the most important feature in the system. That'd be a very low value feature. But it means if it's got a lot of open or even a lot of historical defects, that it's got a higher probability of failure. So again, probability versus impact. They're both important. You just have to factor them together. Another aspect would be what I call critical user flow. This is basically looking for parts of the system where if it fails, bottlenecks you from doing something else. So an example here would be the login page. Most people don't rate the login page usually as a very high priority feature, or if you do and it's released, it's done, it's fine, it's good. The problem with the login page is, whilst it's not intrinsically an important feature, if you can't get to anything else behind the login page because you can't log in, then it obviously is a real failure. So it's what we would call a convergence point. There are several points where users get funneled through the application and then out to other parts of the application. And the login page is only one example. There could be other pages too. And basically, anytime your users go through one of these convergence points, there is a greater impact if that was to fail. If the login page is broken, no one's going to get into the system. No one can then use the important parts that you do care about. So that, therefore, is an important part. And there are some tools which will show you here. For example, this came from Google's user flow feature. If you use Google Analytics, there are other tools as well. It's basically going to measure your user flow. And it's not just bottlenecks in terms of the getting to other parts of the system. It could also just be looking at Google Analytics and saying, wow, loads of users read our blog. Loads of users go to the blog, and then from the blog, they then go and buy our software or buy our service. Because we have found in a customer journey that going to the blog or going to the review page or something is really, really important to them in their buying journey. And if that page is broken or that page is bad, it has maybe spelling mistakes even. If that page has problems with it, whatever it is, even though it's not a technical critical page, it doesn't stop you going somewhere else. In the user journey, it actually appears to be. So use Google Analytics to your advantage. Look at where the users are actually going, see where the bottlenecks are, and see where your critical pages are. Because those critical high traffic pages that force people, or people go there before they go elsewhere, need to be tested more than other parts of the application, because if they fail, the business impact is greater. And we often forget about this. Another thing I would talk about is code commits. Here's a simple code commit graph. You've probably seen these in various tools. It shows you the number of commits going to each branch. What you can usually do is, if possible, is tie this back to a specific part of the system, to a module, tie it to a specific feature if you can. Basically, if in the last sprint we committed a whole bunch of code that affects this one feature, this one module, then there is the possibility that there's problems with it. Now, that's not because developers doing work is bad. It's good. It doesn't mean there's going to be a problem. Remember, risk management is not about what's certain. It's only what's possible. We do know that the more you change something, the less likely its existing tests are valid, the more likely a mistake will be made, cut and paste or some other error. It's just more likely there's something that needs to be looked at. So if you look at your code commits, trace them back to the different features. Hopefully you tag the commits by user story, whatever you're using, whatever tool you're using. Tying that back makes it much easier to say, this module, this feature, this user story has lots and lots of changes recently. Let's write some more tests. Let's focus our test plan on that part of the system, because even though there's not necessarily any greater impact, we just think the probability now is higher, at least for this next couple of sprints. So code stability, effectively. So, okay, we talked about a lot of different metrics. Now let's put it all together. So what I did here is I took my existing matrix and I added some more levels to it. So the top part is the same. We have all these risks, which I would call your classic risks that you've identified from using the risk tree structure that we first did. We've identified the risks, we've rated them by exposure, we've mapped them to the test cases. In the top, we did that already. And the things that are red are obviously bad. The things that are yellow or green, less bad, less exposed, I should say, not bad. So we know which tests are more important. What we did then is I took then the requirements that you have. So these are the top main 5 user stories. Now, this is only a small example. There's only 5 user stories or requirements. In real life, there'll be a lot more. Obviously, just for today, to keep it easy to see, I've only put 5 in here. And I then included, well, what was the probability? That's the business probability, priority. High, medium, or low. That's the first column. So we have a really high feature, a medium feature, and a low feature. And then I looked, how many defects have we had against this feature? Put that in the second column, number of defects. And the third thing I did was put the number of recent code commits, say in the last sprint or so. And anytime we have a very large, out of the ordinary number, I put it red. If it was fine, it was yellow, and if it was low, I put it green. So just a way to sort of get some kind of comparison. And this is just an example. And then what I did is for each row, I then mapped those requirements to our test cases. So we have requirements test coverage. We know which tests cover which requirements. We knew that already. What I did now, though, is anytime I had a priority 1 or a red number of defects or a red number of commits, I put those test cases as red on that row. Anytime there was nothing that was a red, but it was orange, I made it orange. And then finally, same thing for yellow or green. So I basically took a worst case assessment for each of the requirement rows, took the color of the priority, the color of the defects, and the color of the commits. And if any of those 3 were red, then that row was red. If any of those were yellow-orange, it was yellow-orange. And if it was all green, I don't think we have any of those, then it was green. Okay. And then what I did is I put those same test cases and I lined it up with the test cases from before. And I then created at the bottom, and this is the cool part, an overall risk rating. So again, we've only got 10 test cases. In real life, you'd have a lot more. These are my top 10 test cases. And if you'd use a risk-based approach, what you're going to find is that the ones in red, so test case 1, 2, 5, 6, and 8, are the most important. And if we only have enough time to test 5 test cases, we should test those. If we have time for 3 more, then we should do test case 4, 7, or 9. And if we have time enough for 10, we would do the green ones, 3 and 10 at the end. And that it will be using a risk-based approach to prioritize our test plan, using risk metrics, classic risks that you've identified, also using other metrics like requirements, priority, requirements, defect density, requirements, chain test case coverage, and requirements, number of code commits, basically code stability. Putting all those together into this matrix gives you a risk-based approach to test plan. Now, this is all manual. There are tools that can help you do this. You can do it in Excel. You can use tools. In my opinion, there'll be AI-based tools that will help do a lot of this in the future, where computers will actually do a lot of this analysis and big data. So again, depending on the complexity of your project, you can do it in Excel, or you can use a tool. It's up to you. But that is a great way of understanding where is the risk on your project and where should I focus my testing time. But what would Donald Rumsfeld say? And I brought him up because I don't know, maybe it's controversial. It's 20 years of Afghanistan we've left, and so he's top of my mind recently, all that stuff that happened here in America. But what would he say? Now, one of the things that he's famous for, and everyone made fun of him at the time, was there are knowns and there are unknowns. There are known knowns, there are known unknowns, there are unknown knowns, and there are the unknown unknowns. And the thing about risk management is we have been focusing mostly on the kind of the known unknowns. So we know known knowns are the issues. We know what it is. We know that it's going to happen. That's an issue. Number 2, there are things we don't know what's going to happen, but we know what they are. Those are the risks, right? We know there's a risk that the platform is going to be obsolete, but we don't know how likely that is. But then there's the unknown unknowns, the things that we do not know that we do not know. And those won't really figure in our matrix, because if we go back a second here, the risks we've had to identify, so we knew what they were. Well, the requirements, we know the priority, we've decided what they are. We've also looked at the defects from historical and looked at the code commits. The problem we're running into here, though, is the business priority, the requirements, we kind of, that is sort of a known thing, but particularly the number of defects, that relies on past performance being an indicator of future performance. And as we know, that's not always true in testing. You'll find a day 1 bug, something that no one anticipated. You'll find something, the code, we made one change to the code, but it was a change that unanticipatedly broke something. So there was only one commit. So the danger with this risk-based approach is, whilst it will find all your known unknowns, it doesn't find your unknown unknowns. And so when you're building your test plan, it is important to leave time for the unknown unknowns. So if you use a risk-based approach, maybe that will figure out how you spend 90% of your time, but use a technique like exploratory testing or any other free-form, non-scripted or non-deterministic approach to testing. Because you've got all these requirements, you've got your stories, you've got your automated checks, you're doing your risk-based testing. Now, the actual system looks like this. It's got things that the requirements only define what we know about the system. It defines only the tests we know to do. When you put them together, we always have these edge cases, things where we didn't expect the behavior, we hadn't anticipated the behavior, it wasn't documented the requirements, that we didn't think of it as a risk, we didn't know it was a risk, the code wasn't changed much, but it changed something in an unanticipated way. So what I would say is use exploratory testing as well. Don't use a risk-based testing approach solely. It is always important to build in time for people just to look at the system and ignore all that risk-based approach for a short amount of time and just go look around. What can you find? Because I guarantee when we use a risk-based approach, we find a lot of stuff, which is great. And I guarantee you, whenever we do the final, let's do some exploratory testing, the system is a release candidate, it looks really good, we're going to release in a week, but let's just make sure we didn't miss anything. We always find something. Some is something small, some is something big. Something in the installer, something we didn't know. So risk-based testing is really good. It gives you a lot of metrics. It gives you a lot of tools for planning your time, prioritizing, being able to understand risk, but also allow time for the unknown unknowns that might trip you up. So wrapping up this presentation, before we move into the Q&A, I would just say a risk-based approach lets you focus your effort where you'll get the most results. That's not just the most results in terms of the business, but also technical risk. It will find the most important and most dangerous, most exposed parts of the system. It will let you focus where the testing is going to be most valuable. So you'll spend less time testing things you've already tested, testing things that potentially would have less impact. It lets you focus on the areas that will address the most likely risk that you'll be dealing with, the most exposed parts of your system. It's really useful to do this. Make sure you do consider both impact and probability. I do find we often focus a lot on impact. There's a thing called risk bias, where I think we as humans tend to be overly concerned about impact and under concerned probability. Things that are critical but very unlikely, we tend to get very worried about, and things that are moderately likely and maybe not quite so bad, we tend to underestimate. And so that's the thing. It's that middle, it's that top middle, I would say, is the area where you need to focus on, because the things that are really bad are obvious sometimes. It's the things that are pretty bad and quite likely are the worst ones. And I think people that often, when they're looking at mitigations and mitigation strategies like certain tests, will focus a lot on how do we reduce the impact versus how do we reduce the probability. And then lastly, just to, again, beat the drum for free-form approaches, especially as we do more AI-based testing and more AI-based risk management of tests. The more we do that, the more we still need to allow time for unknown unknowns. Don't fall into the trap of feeling like you've planned everything perfectly and nothing will get through that. It never happens. We always find at least one thing, and occasionally it's something important. So with that, there is further reading if you'd like to learn more about risk-based testing. A couple of links here. I will be sharing the slides afterwards, and I will also share that spreadsheet again. It's a very simple spreadsheet. It's not something that we've used. It's a cut down of what we'd use for real, but it gives you an idea of how you could use it. I will be sharing those with the Slack channel and online. And with that, I think it's time for questions.
That was great, Adam. Let's start with the most popular question. But risk rating is very dependent on personal opinion. Do you have tips how to minimize these?
Person's opinion, risk rating, how to minimize this. So what I find is if you ask people which are the most important risks, that everyone has an opinion. I find if you focus very much on one of the, so if you ask someone what's the most exposed risk, everyone will have an opinion. But I find if you get a group of people together and you have a number scale, focus on the probability and then focus on the impact. Don't ask people to do one at the same time. Because if you ask someone, oh, how likely and bad is this risk? They'll be like, well, it's a really bad risk. No, I didn't ask you that. Well, how likely is it? And the other thing is, how likely is it compared to these other risks? So I would say really focusing people on the two different measures. People have a much harder time putting the two together in their head. They'll overestimate all kinds of risks. So I would say really focusing on one metric, the probability, getting everyone to agree that, and then hide that, and then bring up the impact. Do it separately. People have a much easier time with that. The other thing I would say is, if you have a lot of problems with this is a technique we've used a lot. Don't have 5 values, only have 4. Because in most situations, if you give people 5 choices, 1, 2, 3, 4, 5, everyone's going to say, oh, it's a 3. Everything's a 3. The whole world is a 3. So what we would recommend is do only a 4-point scale, 1, 2, 3, 4, for both probability and impact. When you've got no middle value, people have a hard time. They have to pick either 2 or 4, and that's really the important ones. Because then people have to decide, is it really bad or is it not bad? Everyone wants to put everything a 3. So if you put 1, 2, 3, 4, people will have to at least make a choice. So I find that makes it easy if people have a hard time making a decision.
Thank you. Next question. The version 1.1 release may not be ready in time. Could you elaborate what kind of test case could mitigate this kind of risk and the wow phase?
Right. Yeah, and that's right. And those risks came from a risk register that's a mixture of business and schedule risks. That's more of a schedule risk. So that's not one you could mitigate so easily with the test case. I'll be honest, as an example. But I would say that what you have to ask the question is, the risk is, why is it late? Why is it going to be ready on time? Is it you have to take that risk and decompose it? Is the risk that the user that the coding isn't done? Is the risk that the environment isn't ready? Because if the risk was the environment isn't ready, maybe you could find alternative environments ahead of time, and that would reduce your risk. Test the environment. The other thing would be, if again looking back at the release, maybe there's 5 user stories in this release. You could do some usability testing ahead of time to find out, well, if we only could release with 3 features and not 4, which 3 features should we release with? And testing, usability testing, some kind of A/B user testing, where you could have users have some of the features, feature 1, 2, and 3. Another example, users have features 1, 2, and 4. See which of those users prefer. You could then have a scope management plan in place that would say, if we can't release everything, our usability testing has told us that this is the most important thing. We'll go live with reduced scope. So testing can be used to help mitigate even a scope management risk. Typically, I would say you're obviously thinking more about technical risks with tests, but it doesn't have to be.
Great. Let's do the final question, I guess.
Okay.
Next most popular is, could you recommend any tools for visualizing risk?
Well, I should be careful. I should be careful here because my company makes a tool called SpiroPlan that some of the screenshots came from. Because this is an educational talk, I didn't put the product names anywhere. So we do have some tools that do that. We have a web page with a list of risk management tools. What I can do is I can share that link of a list of tools out there. That will be more, I think, objective. I will share that link with the list. But I'll do that, no problem. An exposure, if it's okay, there's a question about exposure I saw. Exposure is when you multiply probability times impact. So let's say you have an impact of 5 and a probability of 5, then an exposure is 25. It's just a simple multiplication of the 2 values. But the important thing is, if you have, sometimes some customers will prefer not to use a 1, 2, 3, 4, 5, but they'll do like a 1, 2, 4, 8, 16 geometric scale, because they would say that a catastrophic risk is much worse. It's not just slightly worse than a critical risk, it's much worse. So you could make one of the scales not linear or both. Particularly if you make one linear and one geometric, it will make that scale much more important. So the probability will be less important than the impact, or vice versa. But it's as simple as you multiply the 2 values. It's how exposed is your organization to that specific risk.
Great.
Should I keep going with the other questions, or do we have time?
We have about 12 minutes until the next session.
Okay.
So if it's okay for everyone, why not?
Okay.
Really?
If it's okay, I'll just go down the list if that's all right. The question is, at what stage of the project should we start risk rating, and how many times should we restructure them? Well, definitely at the beginning. Whenever you're doing a user story development and you're doing your initial planning with the clients or stakeholders, you should do the first part, which is to break down all the risks, do the risk tree, figure out all the risks are top down, and do that for sure. I would say at the end of every sprint, as part of your retrospective, if you're doing Agile, you should probably go back over them and at least make sure and see what's, what the current state is. For risk-based testing, there's a couple of links in the presentation. I can send some more for people if you'd like, not a problem. What kind of metrics do you apply to estimate the risks? Well, some of that was in the presentation. There's the exposure, there's the probability, there's the impact. There is one thing I didn't put in here, which is there's a whole class of risk-based testing or risk management, which is even more detailed. It's used for hardware systems. So I'll give you a second to talk about that. It's called FMEA, failure mode, something or other. It's basically used in hardware and medical systems. You have a third value. You have probability, you have impact, and you have detectability. We didn't put that in here. It makes it even more complicated. And then you have 3 numbers to multiply. And the reason why they do that is because sometimes you have a risk that's hard to see and hard to find. That's a worse risk than it's a risk that's easy to see. This comes when you're dealing with hardware systems. It's not so much in software. In hardware, you imagine you're building something physical. Maybe it's an Internet of Things device. It's a smart fridge. There's obviously the software on it, but there's also the hardware on it. If there's a risk and it's hard to detect, it actually means it's less likely you're going to find it. So it means you've got to look and test for it more. Something that's easy to see is actually less risky because everyone will see it. So there's a thing called detectability, how easy it is to detect, and that's a third metric. Which some risk management methodologies will use a third metric. We didn't do that to keep it simple. Beyond that, I would say code density, requirements, incident defect density. Those metrics are the ones I would look for. And the last question: how detailed should the risks be? I would say as detailed as helps you understand the risk. I don't think there's any real answer. I mean, I would say more detail is better. Like, for example, where it said the risk is the release will be late. That's not a very good risk, because when I answered the risk, it was hard for me to understand exactly what the risk was. Well, the risk is it's going to be late. But really, is the risk that the software is not, the code is not ready? Is the risk that the environment's not ready? I probably would break that down one more level and make it a bit more descriptive. If your risks are not well defined, then the chances are your mitigations will be harder to think about. If you ever get a situation where you have a risk and you don't know how to mitigate it, I would suggest it's probably not defined well enough. It's probably too high level. Take that risk, decompose it. So if there's a risk, the release is late. I mean, a mitigation to that would be double the size of the team. But that assumes that the risk is because you can't code fast enough. If the risk is because the environment won't be ready, then that doesn't help at all. So I think really looking at the mitigations, if the mitigations are hard to design, then you need to make your risk more detailed. I think, is that every question, Roman?
I guess that's it. Thank you very much. And see you everyone in 8 minutes on the blue stage.
Thank you, everyone. Have a great rest of the conference.
Thank you.